Hey, welcome to Unit 1, Lesson 1 about writing methods and functions of our online intermediate Java class. So in this unit, just to tell you what you're going to be learning, we'll be focused on methods, also called functions. I'll kind of use those synonymously. They're not 100% the same word, but they're pretty close. For our purposes right now, you might hear me use either of those words. And then finally, we'll be talking about arrays, and that'll be in a couple days. For today's lesson, you're going to be learning about methods and how to put functionality inside them. You're going to be learning how to use a debugger, which is a critical tool, and that's going to be in VS Code. So make sure you have VS Code set up from our setup lessons. You're going to be learning a new data type called Boolean. And finally, you're going to start using a tool called CodingBat. If you haven't used it before, it's a great, nifty online tool to practice some coding. So that's today's plan. So let's relate functions back to what you already know. And that's math functions. So if I gave you two functions, f of x equals 2x plus 3, and g of x equals 5 minus x squared, you could look at these and you'd say, oh, I know how to evaluate those. If you asked me for f of 7, in my head I'm going to substitute 7 for x, and I'll get 2 times 7 plus 3, and I'll end up with 17. Likewise for g, if I said g of 4, you would substitute 4 for x, so 5 minus 4 squared, which would end up being negative 11. If I nested them inside of each other, I said g of f of 7, you'd say, well, I need to figure out what f of 7 is first. And we already know that from the first one, so we get 17. And then we can say, what's g of 17? And we would evaluate that final problem. Likewise, you could also nest f inside of f and get f of 7. So again, it would be f of 17, which would then result in 37. If that makes sense for math, well, what we're going to do in computer science is very much the same thing. So let's jump over to Visual Studio, and please program along, don't just watch. You'll learn far more by coding along. Pause me, rewind me as you need to do so. So if you jump into Visual Studio, you might have Hello open. We can close that from last time. And let's create our new program. So we're going to go up onto this top bar of the workspace, and you just click on the file, and we can say Lesson 1, and we'll say Functions. And don't forget to put the .java in there. And it will kind of set up the file a little bit for you. It'll give you the public class. And we want public static void main. If you type main and then control space, it will pop up the code for you. You just need to hit enter. Otherwise, you can type public static void main. Okay, so continuing on. Let's create our first function. Well, main here is a function. Everything we've done previously has been inside of main. So let's move that down a few lines and declare our function f. So we're going to say public static, just like we did for main below. This time we're going to say int. That's called the return type. We're going to have a couple slides on that in a minute to describe it. F is the name of the function. So when we said f of x, f was the name of the math function. So here f is going to be the name of our Java function. And then we're going to, just like in math, we have our input of x, right? We need to give a data type for that input. So we're saying, okay, x is always going to be an integer. It won't have any decimal values. So public static int, the name of the function f, and then whatever its inputs are. And here we can do our calculation. So I'll say, okay, result is going to be 2 times x plus 3. So that will use the x that was passed in, and then we can return whatever that result was to whoever called us. And return is a very magical function. And so let's kind of see what's happening here. And so I'll say int something. Something could be any name. So that's why I'm picking just something. And I want to evaluate f of 7, because that's what we evaluated before. Put a semicolon at the end. So now we are calling the function f that we defined. We're passing the 7. 7 will become x. This will then calculate something called result, and then result will be passed back to us and go into something here. And so let's do system out print line to print it out. And I will say f of 7, just to get a nice label in here, equals and plus something. So it's going to combine what I had and print it out. So let's run that just to see that it runs correctly, and then we're going to use something called a debugger to understand what's happening a little bit more. Again, you're just going to click on the run here to execute it. You'll see the results down at the bottom, and I'll see f of 7 equals 17. Let's see what's actually happening. So right to the left of the 9, or whatever number you have here. You're going to click it so you get a bright red circle. This is called a breakpoint. And this time, instead of hitting run, hit debug. What's going to happen is the program is going to start, and when it reaches this line, line 9, it's going to stop. So the program basically stopped as soon as it started. And now I can control it step by step so I can watch what's happening. Up at the top, you get this nice little toolbar, and we want to follow the step into. And step into means you'll step into a function. If I do step over, it would kind of execute the function, kind of skip over, and we wouldn't see what's happening. So if I hit step into, well, then notice that it comes inside here. So we went from this line all the way up to this line, because this is what's called a function call, which passes control up here. We have some variables we can watch here. So if we put plus, and we can type x, that will show us, oh, the variable x in this context is 7. So we passed a 7 up, and the x became 7. If I click and do result, it's going to say it doesn't have a value yet, and that's fine. So now let's step over this line. The step into is fine. Step into or step over would have been equivalent there. We now see the result is 17. If I step again, we'll see the control is passed back down to this line. Now let's start watching something. Something will still not have a value because this line hasn't executed yet. So it shows me that that's what's going to happen next. And if I step one more time, we'll now see that something, I spelled something wrong, something will now have a value of 17. And so the result passed back and became 17. And then when we print it, just do step over. Whenever you're doing print line, if you do step into, you'll go into the systems code, and it gets pretty deep pretty fast. So just do step over, and I'll skip over the statement but still execute it, and then you'll get the printout. And that's how functions work. So let's add our second one. Let's add function g. So public static int g, and this also takes an x. We can take an arbitrary number of arguments. We'll talk about that in a few minutes as well. And I will call this, let's call this result as well. I could call this anything I want. Result is just whatever name I want to call it. It doesn't actually matter. And so I'll do 5 minus, and this is supposed to be x squared. So I could do x times x or math pow. And I'll do x times x. And then I can return result. And so let's do what we were saying before with the nesting. So I will say g something. And this is going to be g of f of 7. And then we can print this out. And so I'm going to copy this higher print statement, put it here. Again, please type along rather than just watching, because you'll learn stuff when you type things wrong and you need to debug it and so forth. So this time, let's leave that breakpoint there and we can see how this works. So go ahead and hit debug. And it stops at line 13 like before. And what we're going to do this time is do step over. So we don't want to go into this first thing. We already understand those. But when I get here, I want to see what's happening next. So I'll do step into and watch what happens. So step into comes up to F, and we'll be able to watch these things. Oh, by the way, I'm going to get rid of this wrong something here. Remove expression. Okay, so I'm going to step through, and we'll get the same result as before. We get 17, and when I come back down, now I'm down here in G, so it shows me that I'm here again. So F of 7 has result returned. Now when I come in, the next step is going to end me up in G. So it did the F function, now it did the G function. If we look at what X is now 17. Right? There is no X down here, right? So it's not like we're passing a value by the name of X, just by position. Since F of 7 is here, that evaluates as 17, which then gets passed up here, and we call that X. We'll do our calculation, and then we get negative 284, and then we'll return it. And that's it. So you could, once you're done and you just want to tell it to just keep running, you can just hit the left side continue, and it'll run until it exits. So there you have it. Those are our 2 sample functions. Let's add actually one more function, and to just illustrate 2 other things. So let's do public static double h, and let's do the product of an integer a, and a double b. So we can take multiple arguments. So this time I called them a and b, and I'm returning a different data type. This time I'm returning a double. Now the last two times I've created this intermediate variable called result. That wasn't really necessary. We can do all sorts of things in here. So let's do a system out print line and just say printing hi in H. So we could put whatever we want here. So a function does not just do calculations. It can do all sorts of other things. But then when we want to return, we can do whatever we want in the return statement as well. So I don't need to do that intermediate int result or double result thing. I can just do the calculation and return it at the same time. And a function is not just for calculations in Java like it is in math. You can do all sorts of things. So finally, if I call, let's nest it all together here. I could do system.out.println, and I can say h colon plus h at 2.3. So in a sense, so println is a function, is a method that takes a string, and then this string is taking two arguments. It's taking a string and it's taking a function that will return a double that will get converted to a string. So the first thing that's going to execute is this guy. And if we want to see what's happening, we can put a breakpoint up there. And then go ahead and hit debug again and run it. So you'll see that the first two statements already printed the f of 7 and the g of f of 7. We're now inside of H, so we could add a listener for A and B. And you'll notice that A is 3 and B is going to be 2.3. And then so if I'm going to step over the print function, we'll see that it appears down here. And then I can do my calculation and return, and then I step over that and I'll print out the result. And so again, we're seeing how functions can work in Java. Let's jump back over to the PowerPoint, and let's talk about how to read a function declaration. So we've seen pieces of this now, and let's go through each of the pieces individually. So we have public static int, get product, and then int x and int y. So the first word in this is public. So this is called an access modifier. It's kind of like social media where you can mark something as public just for your friends or as private. In Java, this is not about security, but it's about visibility. So if we say public, it means all other classes in your program can see it. So it's just talking about things in your program. It's not talking about the world at large. But what classes in your program can see this method or this object? So that's public. Private means that only the current class can see it. And you'll understand classes more once we get to Unit 2. And protected is kind of like the friend state, where some people can see it, or in this case, some classes can see it, but others cannot. So those are the three levels of access modifiers. For now, everything that we do is going to be public. For a second one, let's talk about static. For static, again, this is another topic for Unit 2. Everything that we do now is going to be static. Basically, it means that we're not working with an object. We're just creating a method. So we'll learn more about that once we get to Unit 2 and we know the difference. But everything for now is static. So everything we're going to do so far is public and static. So this is where it gets interesting and changes based upon what we're doing. And this is the return type. So when a function finishes, it can return a value to whoever called it. This is called the return type. It's kind of like its output. And so since this one's called int, it's going to return an int. It's going to, it could say double, it could say string, it could say mouse if it returns a mouse object. If it doesn't return anything, you put void where int is. After that, we actually have the function name. I don't have a slide for it, but this is the name of the function. And then we have the parameter types. So then we have the two parameters, x and y. And then we have the types of those parameters. It could be any data type that's valid, double, string, int, frog, if frog is a valid type in your program, and so forth. And these names are arbitrary. They can be anything that whoever wrote the function wants them to be. They don't correspond to anything in the program. All parameters are passed by position. So let's practice a couple. I scribble this down on paper, pause me, and then try to answer it. So write a declaration for a method called Firefly, which takes two parameters, one double and one string, and that returns an int. Don't forget to pause me. So you go public static int firefly AA and string B. And A and B are just the names that I used. You could have used any name you wanted. Again, those names do not matter. Next one, write the declaration of a method called giraffe, which takes no parameters, and that returns a string. Public static string, giraffe, open close parens. So if there are no parameters, you just leave it empty inside the parens. Next one, write a declaration for a method called dolphin, which takes a parameter of type fish and returns nothing. So public static dolphin returns a void. So public static void dolphin returns nothing. And it takes an object of type fish, and we can call that whatever we want, and we'll call it lunch. So let's continue what we've been learning here and talk about a new data type. It's going to be a Boolean data type. Actually, specifically, I should be writing this with a lowercase Boolean here. Both are true. It can be capital or lowercase, but I'm really talking about the primitive type here, so it should be lowercase. And some of the primitives that you know already are ints, which are whole numbers, and doubles, which are decimal values. And then you know what's called a string. That's a type of object, and that's a collection of characters. It's words and so forth. So we're going to add a new data type to this mix. So a new type is called Boolean, and it only has two values, true and false. And if you've done truth tables in your math class, that's the same concept. So I imagine we declare a variable called comp, and then we assign it the value 5 is greater than 7. Well, is 5 greater than 7? No, of course it's not greater than 7. So 5 greater than 7, this comparison evaluates the true or false. We can then assign that to a variable of type Boolean. So in this case, this will be set to false. And then we can say, okay, if comp, so since comp is false, this thing won't run. So this is how you can use Booleans in an expression. Now, it is possible you could say if comp is true, but that's kind of redundant. And actually, if you type it in Visual Studio, we'll probably say, hey, you don't need that equal true thing. You might as well just say if comp, because if comp and if comp equals true is equivalent. We've already used and or operators, and even not operators. And so we've been using Boolean operations already. So let's put some of these things together. I'll evaluate each of these in your head, and I'm going to say the answers here momentarily, so you can pause me and write down the answers. So 10 modulus 2, does that equal 0? Yeah, so 10 modulus 2 is saying, if I divide 10 by 2, what's the remainder? And the remainder of 10 divided by 2 is 0, so 0 does equal 0, so A is going to be set to true. Not means invert whatever the value of A is, so if B is not A, then B is going to be false. I can say A and B. If we recall from prior learning, A and B, C will only be true if both A and B are true. Well, since B is false, C is going to be false. For the next one, or says that as long as either of these is true, or both of them is true, then D will be true. So A is true. So we don't care what C is even. Since A is true, D is going to be true. Because if one of the arguments is true, then the whole thing is true. Now we can put this whole thing together, and we can say, okay, let's A and D. So A is true, and D is true. So A and true is true. And then we're going to say B or C. Well, B or C, neither of these is true. So this is going to be false. So we have true doesn't equal false, which is true. And that's where we get a true here. So let's jump back over into Visual Studio and just do another practice with coding these guys. So let's close this program. Again, to stop this, hit the stop, and you can close him. And navigation, on the left side, just click on the very top, and then let's create our next program. So we'll do lesson 1, and this will be Booleans, just to give you a quick demo of how these work. I'm going to copy and paste some of the code this time. So let's create our main, and actually I'll paste a couple things in. And I'd appreciate if you type them because that's the way you're going to learn. So putting in public static void main, and then we're going to say, okay, Boolean A is 4 greater than 8. Well, 4 is not greater than 8, so when we run this, this should say true. Oh, this should say false. So go ahead and run it and prove to yourself that it's false. And then let's put in some ors and ands. So we can put in a second one. So we could say, okay, 16 modulus 4 equals 1. Well, this isn't true because 16 modulus 4 is 0. 15 modulus 3, well, that's 0. So the right side is true, and this is an OR. So if one of them is true, then the whole thing is true. So if we run that now, B will be true. Now let's write a method that will return true if a number is divisible by both 4 and 5. So public static Boolean divisible by 4 and 5. And we'll take an int n. Now we could do this in one line, but I would like to just do it in a couple lines so we understand what's going on. And actually in this case parentheses are not necessary, but it just feels better to me, so I'm putting them in. So what I want to do first is do a calculation for both divisibility by 4 and divisibility by 5. And then I can return A and B. So this is just like our numeric function before. We're just working with Booleans. We're returning a Boolean, we're taking an int, do some subcalculations, and then return the final calculation. And so if we come back down and we just do, we can type sys out, control space will open that window. And so now we can just say divisible by 4 or 5, and we could pass it, say, 24. And so that should be false that time. And then if we call it again and pass in 40, it should be true. So let's go ahead and run it and just verify that this works. And so indeed the answers down at the bottom are correct. Okay, back to PowerPoint. Please run that if you did not do so. Finally, your assignment. I would like you to learn how to use CodingBat. CodingBat's kind of a fun interactive site. It gives you just good practice to strengthen your skills. The more you practice, the better you will get. So go to codingbat.com and create an account. I'm going to ask you to use your Bergen credentials. So create an account with your Bergen credentials. For your password, do not make it a secretive password. Maybe 123456 or something like that. Do not use your Gmail password or anything like that on here. So just create an account with a simple password. You write it down, and I will get logged in as well. And once we're logged in, I would like you to click on Prefs. So create your account. Once you're in, click on Prefs. And in here, you're going to do two things. First of all, under Teacher Share, you're going to put my name. This way I can see your progress. So just type briarrest@bergen.org, hit share. The screen will not refresh in any way, but at that point I will be able to see your work. The second thing is I would like you to put in your last name followed by your first initial. So let's say your last name was Kim and your first name was Rachel. You could do Kim, R. And then hit update memo. And that just helps me to see who you are when you're doing the work. Okay, so let's go back to the site and show you what you're going to need to do. So your assignment, I believe, is to do warm-up 1. Logic 1. You do logic 1 and you're going to do 12 of them. So let's go look at logic. And these are fun little challenges. This is written by a professor or maintained by a professor out in Stanford. And it's really quite nice. So let's do caught speeding. I already finished cigar party, so let's do caught speeding. You're going to need to read a little story. So it says you're driving a little too fast and a police officer stops you. Write code, compute the result, encode it as a value 0, 1, or 2. So we're going to return a 0, 1, or 2. If our speed is 60 or less, the result is 0. the speed is between 61 and 80, results 1. If it's 81 or more, I return 2. If it's your birthday, your speed can be higher in all cases. Okay, so there's lots of ways to attack these, and there can be all different correct answers. So I'm going to kind of go top down this time. And I'll say, okay, if speed is greater than or equal to, less than or equal to 60, return 0. Now, one thing we didn't see in our practice is you can have multiple returns. And now I can say else if, just like you did previously with if, else, so forth. I can say if, else if speed, I could use the 61 here, but I don't need to because I already took care of the 60 and below, so I'm guaranteed that everything's 61 or higher. I can do less than or equal to 80. And it says inclusive, so it'll be less than or equal to, and I'll return 1. And then otherwise, return 2. So if it's higher than 80, return 2. Now, if I hit go, it'll only work for some of them at this point. And when we run it, basically we'll see, okay, if I pass in a 60 and false, I got the correct answer. If I put in 65 and false, I got the correct answer. When I put in a true, I got the wrong answer. And down below, down farther down, I'll see if I put in a true here, got the wrong answer. So I'm getting it wrong when it's my birthday. So the reds are telling you the cases that you're getting wrong. Okay, so now if we go back up and we want to fix it, we're going to go up to the beginning. We can say, okay, so if it's my birthday, this is going to take a little thinking here. If I could go 5 miles per hour faster, that means if on my birthday, I'll pretend like I can subtract 5 miles an hour from the speed. So if I was going 65, the cop only sees me at 60, and so forth. So if it's my birthday, decrease the speed by 5. And when I hit go, we'll see that they magically all are successful. And I'll say that they're correct, and then you can go to the next one. You need to do 12 of these. I can certainly take a look and help you with them as you get stuck. But if you're able to, you may do all of them. This is good practice, and I'll meet with you for lesson 2. Good luck.